Welcome back to Relax and Learn with Valearnis. Today we'll be covering the early Earth. Not literally, mind you. That would require a really large blanket. But instead, let's cover it figuratively. Lay down and relax as we slowly drift back 4.6 billion years. You may be about to say, well, isn't the Earth only 4.5 billion years old? And you'd be correct. However, to talk about the early Earth, we must first touch on the solar system, just a mere 100 million years older than our big blue Earth. As you may recall from last week's episode, the early solar system was a dense, inert molecular cloud, a leftover, a remnant of an older star. Our solar system may seem old, but as our universe is a lot older still, a lot came before it. As that cloud settled, it grew denser over time, collecting more and more material. Eventually, once disturbed by the blast of a neighboring supernova, quite rude if you ask me, it began to collapse in on itself. The shockwave caused the cloud to spin, leading to the formation of the protoplanetary disk. The center of this disk held most of the mass, eventually collapsing into a protostar, the baby stage of our big beautiful sun. On the edges of this disk, the remaining gas, dust, and rocks began to form into planetesimals. As these planetesimals collided and combined with each other, we eventually came to the formation of the protoplanets, early versions of Mercury, Venus, Earth, and so on. Let's take a small step forward now to around 4.56 billion years ago. Imagine drifting amongst the vastness of space in the early solar system. The planets have mostly formed, but the neighborhood is still incredibly hot, with a lot of chaos and unpredictability. Things haven't fully settled down yet. Your space couch, well, I imagine you listening to this on a couch, maybe you're in a car or on your bed, or whatever you're in, imagine it floating through a busy early solar system, slowly drifting in view of a very young, very hot, early Earth. At this point in time, the accretion phase of Earth's development is almost complete. Accretion is the very chaotic, extremely hot process in which smaller pieces of matter, starting with gas, to grains, to pebbles, to boulders, to planetesimals, to eventually protoplanets, collide and combine together to form planets. As matter is added layer by layer in this accretion process, we're able to have planets like Earth that are structured differently as you go through the core, through the mantle, and through the crust. The accretion leads to differentiation, a vital component of a planet's ability to support life and generate its own magnetic field. But we can't talk about life just yet, as the Earth is still covered in oceans of molten magma at this point in time. A great blue Earth looks a lot more red than you'd expect right now, but give it just a bit more time as things are finally starting to cool down. Chapter 2. Take a breath, enjoy the stillness. The Earth has begun to cool, forming a very thin crust over a sea of molten magma. If you've seen The Lord of the Rings, it looks akin to the magma of Mount Doom at the end. If you dislike my nerdy references, I don't know what to tell you. You're listening to a relaxing educational podcast. It's already a nerdy endeavor. Also, whilst we're on the subject of Mount Doom, our early Earth's peace was interrupted by an unsuspecting character whacking into us. Even though Earth was starting to settle down at this point in time, the solar system hadn't yet followed suit. At 4.51 billion years ago, our neighborhood was a lot rougher than we're currently used to. Comets, asteroids, planetesimals, and entire other protoplanets were barreling through this chaotic early solar system. One such protoplanet was a beautiful celestial body called Theia, an early romance of our young Earth. Alas, as young love often begets ruin, so too did this relationship. Theia was roughly the size of Mars today, a sizable protoplanet by any means, and even worse, her and the Earth's attraction was stronger than what could be deemed safe. If you were still drifting above Earth at this time, perhaps relaxing in the rare tranquility of a planet finally cooling down, your relaxation would unfortunately be short-lived. Theia obliterated her way into Earth with the energy of about 10 billion nuclear bombs. The force of the collision vaporized vast portions of both planets. Molten rock, metal, and dust were flung thousands of kilometers into space, creating a glowing halo of debris that briefly made Earth look like the galaxy's hottest disco ball. For a short while, Earth was no longer a single planet but a chaotic mess of melted chunks orbiting a molten core. But from this cataclysmic breakup came something truly poetic. Over time, gravity began to work its quiet magic, pulling the ejected debris together. These glowing fragments slowly gathered and coalesced until, out of the chaos, a new celestial body emerged. Our moon. Imagine that. Out of a cosmic accident, a companion was born. The moon's formation wasn't just aesthetically pleasing for poets and werewolves, it was absolutely essential for us. The moon stabilized Earth's axial tilt, which meant we'd have consistent seasons and long-term climate stability. It also started to affect the tides, creating gentle pulses across the molten surface and early oceans that, billions of years later, would help life stir for the very first time. But we're still a long way from life right now. In this fiery aftermath, Earth had once again become a hellish world. The surface glowed like liquid iron, volcanoes roared non-stop, and meteorites continued pelting the planet like it owed the cosmos money. Yet amidst this destruction, the planet was slowly healing. Over tens of millions of years, Earth's outer layers cooled and hardened again into crust. Heavy elements like iron and nickel sank toward the core, while lighter silicates floated upward, forming the mantle and crust we know today. With its molten heart churning away, Earth's magnetic field began to form, a cosmic shield that would one day protect all living things from deadly solar radiation. As the fiery storms quieted and the planet started to breathe for the first time, Earth transitioned from pure chaos into the possibility of calm. The stage was set for one of the most dramatic transformations in planetary history, the beginning of water, atmosphere, and the first true chance for life. Chapter 3. The arrival of water and the first breath of an atmosphere. Take another deep breath, hopefully one made of oxygen and not carbon dioxide, unlike the Earth at this point. The year is roughly 4.4 billion years ago, and things are finally starting to chill out a little, both figuratively and literally. Picture it. Our molten planet has stopped cosplaying as Mustafa from Star Wars and is now wearing a delicate crust of rock, cracked and glowing in places like embers in a dying campfire. Volcanoes still erupt constantly, but they're no longer turning the planet inside out every few minutes. Slowly, the air above this young Earth starts to thicken with volcanic gases, carbon dioxide, methane, ammonia, and water vapor. This wasn't exactly a breathable spa retreat yet. The early atmosphere was toxic, dense, and heavy, but it did one very important thing: it trapped heat. This greenhouse blanket kept the planet warm enough to eventually allow something miraculous: rain. Now, this wasn't your typical drizzle. For millions of years, the sky unleashed an endless, planet-wide downpour. It was like Earth had accidentally hit unlimited trial on its weather system and forgot to unsubscribe. Every volcano belched steam. Every meteor impact released more trapped vapor, and the planet wept and wept and wept until the surface began to pool with water. Those pools turned into puddles. Those puddles merged into lakes, lakes into seas, seas into sprawling oceans that shimmered under a dim red sun, still faintly glowing through the heavy haze. And just like that, Earth wasn't just a ball of rock anymore. It was a world of blue. It's a strange thought, isn't it? That everything you've ever known, the oceans we swim in, the rain that falls, the ice that melts, are began as gas escaping from volcanoes and meteors crashing through the sky. Even more poetic is that some of our water may have come from comets, frozen messengers from deep space that slammed into our young planet, delivering a cosmic care package of ice. With water came reflection, literally. The oceans cooled the surface, stabilizing the climate further, and as the crust shifted and thickened, continents began their earliest forms, jagged volcanic islands poking through the endless blue, waiting patiently to become the continents we know today. But Earth wasn't done transforming. The atmosphere for now was still a suffocating mix of toxic gases. The air shimmered with volcanic haze, lightning flashed across sulfuric clouds, and meteors still occasionally said hello, a little too enthusiastically. Yet beneath all that chaos, the stage was perfectly set for something extraordinary. Within these newly formed oceans under crushing pressure, in the dark warmth of hydrothermal vents and chemical-rich soup, the ingredients for life itself were beginning to simmer. Chapter 4. The First Life and the Great Oxygenation. We're now sitting around 4 billion years ago. The Earth has finally started to calm down. The surface is solid, the oceans are deep, and the sky is thick with gases that wouldn't exactly be kind to your lungs. But the stage is set. Beneath the waves, chemistry is beginning to experiment with something new. Picture the deep ocean floor. Volcanic vents bubble like underwater geysers, pumping out minerals and heat. Lightning flashes across the sky above, sending energy into the seas below. Together, these forces create a kind of strange chemical soup. Not delicious soup, mind you. More like something you'd immediately regret tasting. But within this mix, something remarkable happens. Certain molecules begin reacting in ways that make them copy themselves. At first, it's simple, just repetition. But as time goes on, these molecules start forming structures, tiny bubbles that trap chemicals inside, separating the inner world from the outer one. These are the first cell walls, and inside them, the first forms of life begin to stir. These microbes were small and simple, but they were persistent. They didn't need oxygen, sunlight, or snacks. They survived using chemical energy from the vents, thriving in darkness. For millions of years, these tiny organisms ruled a quiet, alien world. Then, around 3.5 billion years ago, a new kind of microbe arrived on the scene, cyanobacteria. These little geniuses figured out how to use sunlight to make energy, a process we now call photosynthesis. In doing so, they accidentally started releasing oxygen as a byproduct. At first, that oxygen didn't make much difference. It reacted with the iron in the oceans, turning them a murky reddish-brown. Over time, the iron ran out, and the oxygen began to escape into the air. Slowly, the planet started to change. The skies turned from orange to blue. The air began to clear. This was the Great Oxygenation event. It was both a miracle and a massacre. The new oxygen-rich world was perfect for future life, but poisonous to most of the organisms that had come before. Many went extinct, but a few adapted, and those survivors would become the ancestors of everything complex that followed. Earth had taken its first breath, and it would never be the same again. Chapter 5. Snowball Earth and the Rise of Complexity. Time has moved forward again. We're now around 2.4 billion years ago, and Earth's brand new oxygen-rich atmosphere has had some unintended side effects. The same oxygen that made the planet breathable also reacted with methane, one of the gases that had been keeping the planet warm. Without enough methane, the temperature started to drop. Slowly at first, then rapidly. Glaciers spread from the poles, reflecting sunlight back into space, which made things even colder. Before long, the entire planet froze over. This was the first time in history that Earth became what scientists call Snowball Earth. The oceans were sealed under thick sheets of ice, the land was buried, and temperatures dropped so low that even equatorial regions were frozen solid. From space, Earth would have looked like a shining white marble, silent and still. But life, stubborn as ever, didn't give up. Deep beneath the ice, near volcanic vents and geothermal cracks, microbes continued to survive. They adapted to darkness, to pressure, to extreme cold. They were patient, and eventually, patience paid off. Volcanoes never stopped working, even under the ice. Over millions of years, they released huge amounts of carbon dioxide into the atmosphere. The CO2 built up, trapping more and more heat until the ice finally began to melt. The thaw was dramatic. Oceans refilled, climate stabilized, and Earth, once again, became a world of blue and green. When the ice receded, something extraordinary happened. The long freeze had changed the chemistry of the oceans. Nutrients that had been trapped under the ice were suddenly released, creating a burst of energy for life. Cells began to evolve new ways to survive, to interact, and to grow more complex. By around 1.6 billion years ago, the first eukaryotic cells appeared. Cells with nuclei, organelles, and specialized parts. These were the ancestors of plants, animals, fungi, and everything else that moves, breathes, or thinks. It's strange to imagine that the world had to nearly freeze to death just to set the stage for life to flourish. But that's how Earth works. Out of catastrophe comes innovation. Out of stillness, growth. The planet had survived its first true extinction event and emerged stronger for it. The age of complexity had begun, and with it, the first steps toward multicellular life. Chapter 6. The Cambrian Explosion and the March of Life. We've now arrived at around 540 million years ago. Earth has thawed, stabilized, and spent over 1 billion years quietly brewing life beneath the surface. The oceans are rich in nutrients, oxygen levels are higher than ever before, and the planet is teeming with microscopic potential. Then something incredible happens. Life decides to go big. This period is known as the Cambrian Explosion, and it marks one of the most dramatic turning points in Earth's history. In what seems like an instant, though in reality it took a few tens of millions of years, life diversified faster than it ever had before. Simple, single-celled organisms gave rise to complex, multicellular creatures with limbs, shells, eyes, and even primitive nervous systems. If you were floating through the shallow seas of the Cambrian period, you'd think you'd stumbled into an alien world. The ocean floor was crawling with creatures that defy imagination. There were trilobites scuttling across the seabed, armored like miniature tanks. Worm-like predators with circular toothy mouths called Anomalocaris zipped through the water. Spiky, soft-bodied organisms drifted lazily, filtering food from the currents. It was chaotic, competitive, and oddly beautiful. This explosion of life also saw the rise of the first true food chains. For the first time, animals were hunting other animals. The concept of predator and prey had entered the picture, setting the stage for evolution's endless game of adaptation. Those who could see better, move faster, or hide more effectively survived. Those who couldn't, well, they became fossils. The Cambrian seas were the cradle of nearly every modern animal lineage. The ancestors of insects, fish, mollusks, and even humans all trace their origins back to this time. It was nature's great experiment, a creative outburst after billions of years of quiet groundwork. By the end of the Cambrian, Earth was no longer a planet of microbes. It was a planet alive with motion, color, and sound. The blueprint of modern life was written here, in these seas. But as life thrived in the oceans, something else was beginning to stir. The land, for billions of years lifeless and barren, was about to change. Tiny organisms would soon begin to make their first brave steps onto solid ground. Chapter 7. From Water to Land, the First Colonizers. We're now around 470 million years ago, and the world has changed again. The seas are full of life, bursting with color and movement, but the land is still quiet. Barren rock stretches from horizon to horizon, shaped by wind and rain but untouched by anything living. It's a silent world, a canvas waiting for its first brush strokes. Those brush strokes come from some of the smallest and most determined pioneers imaginable. Algae and simple fungi begin to creep onto damp rocks near the edges of the water. They form thin greenish films, clinging to life wherever moisture allows. These humble beginnings set the stage for one of the most important transformations in Earth's history, the greening of the land. Over time, these simple organisms evolve into mosses and early plants. They develop roots, stems, and eventually vascular systems that can transport water and nutrients. With plants comes photosynthesis on a massive scale, pumping even more oxygen into the atmosphere. The air grows richer, the sky clearer, and the land starts to smell faintly alive for the first time. Of course, where there are plants, life soon follows. The first animals to crawl out of the oceans weren't exactly majestic. No noble lions or towering dinosaurs yet. Instead, think of scuttling arthropods, early relatives of insects and spiders, making short trips from tide pools onto land. They moved clumsily, probably gasping their way across the rocks, but they were explorers all the same. By around 400 million years ago, small forests began to take shape. Ferns, club mosses, and horsetails grew tall, turning empty plains into dense green jungles. Giant insects buzzed through the humid air, and early amphibians began to slither from rivers and swamps. These amphibians were among the first vertebrates to breathe air and walk on land, using limbs that had evolved from the fins of their fish ancestors. Life had crossed a boundary that had defined it since the very beginning. The oceans would always remain home to many, but now the land had its inhabitants too. Earth was transforming into a truly living planet, one that could support ecosystems across every surface. But as always, balance never lasts for long. The next chapter in our planet's story would bring both growth and disaster, as continents collided, climates shifted, and the first great extinction loomed on the horizon. Chapter 8: The Age of Fish and the First Mass Extinction. We're now around 420 million years ago. Earth is warm, humid, and thriving. Forests have begun to spread, and rivers twist through green landscapes filled with early plants. But it's the oceans that truly dominate this era. This is the age of fish. The seas are ruled by creatures of every size and shape. Jawless fish swim alongside newly evolved species with actual jaws and teeth. Sharks, armored fish, and early bony fish compete for dominance. The water is full of movement and life, a tangled web of hunters and prey. It's during this time that the first vertebrates with real backbones take over. Their bodies become sleeker, their fins stronger, and their jaws more efficient. Some grow to enormous sizes. Others stay small, darting through coral reefs that stretch for miles. The ocean is alive with energy, noise, and constant evolution. Back on land, plants are spreading fast. The atmosphere is rich in oxygen, and the world feels alive in a way it never has before. Insects are diversifying, amphibians are venturing further inland. The planet is covered in shades of green and blue, and for a moment, it feels like life has finally found balance. But balance never lasts long on Earth. Around 375 million years ago, things begin to shift. Continents collide, sea levels drop, and climates change. Massive volcanic eruptions fill the air with ash and carbon dioxide. The oceans lose oxygen, suffocating the very creatures that once ruled them. This marks the first of Earth's great extinction events. Known as the Late Devonian Extinction, it wipes out nearly 75% of marine species, coral reefs collapse, armored fish vanish, and many of the dominant groups of the time disappear completely. It's a sobering moment in our planet's story. Life, through which had come so far, is forced to start over. But from these dark ages, survivors emerge stronger and more adaptable. Among them are early amphibians and reptiles, creatures that will soon take over the land entirely. The age of fish ends not in silence, but in transformation. The stage is now set for a new era, one that will see the rise of forests, giant insects, and the first true land-dwelling animals. Chapter 9: The Age of Forests and the Rise of Reptiles. We've now reached about 360 million years ago. The world is healing again after the first Great Extinction. The seas are quieter, but life on land is exploding with new growth. Massive forests of ferns, horsetails, and towering club mosses spread across the continents, blanketing the land in green. The air is thick, humid, and filled with oxygen. If you were to walk through one of these forests, you'd find it dense and heavy, almost too rich to breathe. This was the Carboniferous period, a time when plants ruled the earth. The trees grew tall and close together, their roots forming vast, swampy jungles that stretched for miles. When these plants died, they sank into the wet ground, where the lack of oxygen prevented them from fully decaying. Over millions of years, those layers of dead plant matter compressed and hardened into something that would one day fuel our own industrial age, coal. But the forests weren't empty. Giant insects roamed these ancient jungles, taking advantage of the oxygen-rich air. Dragonflies the size of seagulls buzzed between the trees, and millipedes longer than a human arm crawled through the ferns. It was a strange, otherworldly version of Earth, both familiar and alien. Meanwhile, the amphibians that had once dominated the waterways began to face a challenge. The climate was changing again. Parts of the land were drying out, and living solely in water became risky. Some species began to evolve tougher eggs and thicker skin, better suited to surviving in drier environments. From these adaptations, the first reptiles were born. Reptiles were the new pioneers. Unlike amphibians, they didn't need to return to the water to reproduce. Their eggs had protective shells, and their bodies were built for life on land. This gave them a huge advantage, allowing them to spread across different environments: forests, swamps, and deserts. With reptiles came the beginnings of independence from water. They became the new rulers of the land, paving the way for all the great creatures that would follow. Their success would carry them into one of the most remarkable and volatile periods in Earth's history, an age of continental collisions, mass extinctions, and the rise of true giants. Chapter 10: Pangaea and the Dawn of the Dinosaurs. We're now around 250 million years ago. The Earth looks very different again. The continents, once scattered, have slowly drifted together into one enormous supercontinent called Pangaea. Imagine a world where almost all land is connected. Vast deserts, endless mountain ranges, and sprawling forests stretching from one horizon to the next. The ocean that surrounds it, called Panthalassa, covers nearly the rest of the planet. At first glance, it might sound peaceful, but life on Earth has just survived the worst disaster it's ever faced. Around 252 million years ago, the Permian extinction struck, the biggest mass extinction in history. Over 90% of marine species and 70% of land animals vanished. The world had nearly gone silent. The cause was a perfect storm of catastrophe. Massive volcanic eruptions in what is now Siberia filled the atmosphere with carbon dioxide, triggering global warming. Oceans turned acidic and lost oxygen. The climate flipped between extremes of heat and cold. It was chaos. Yet somehow, a few survivors held on. Among them were small reptiles, early mammals, and a new group of creatures that would one day define an entire era, the archosaurs. These were the ancestors of crocodiles, pterosaurs, and most famously, dinosaurs. As the Earth recovered from the Permian devastation, ecosystems began to rebuild. Plants returned first, covering the land with greenery once again. Then came the reptiles, adapting and diversifying faster than ever before. The Triassic period had begun, and with it, a new caste of creatures. Early dinosaurs were small and quick, not yet the towering giants we often imagine. They walked on two legs, hunted insects and small prey, and lived in the shadows of larger reptilian competitors. But they had something special: agility, endurance, and lungs better suited to the hot, dry climate of Pangaea. Slowly, quietly, they began to spread. By the late Triassic, dinosaurs were ready to step into the spotlight. The stage was clear, the world was recovering, and evolution was about to go wild. The age of reptiles was here to stay.